This is a portfolio optimization system that we've put together. The idea is that one would have a number of projects. Each of these projects has a value driver tree which calculates the net cash flow, net incremental cash flow attributable to the project, and from there we can work out the NPV, the IRR, and various other financial metrics. One can inspect the set of projects that is currently on the table using this project review screen, and for each of the projects we can get a sensitivity analysis showing what the most sensitive drivers of that project's NPV are. Every project also has an expected case as well as a low road and a high road, which we then use to run a Monte Carlo analysis on the portfolio and get a measure of the downside risk that is associated with a portfolio of projects. Now, one can very quickly and easily drag and drop new projects into the list of projects, and you can basically build up your list of projects from pre-existing templates. Each template would have its own logic for how the net cash flow is worked out, and those project templates can be assembled into a library which is then standardized across the organization. So one can quickly add new projects, and then using the assumption screen we can import and export all of the time series data for those projects, or for one particular project by drilling down to it in the portfolio, and this can be copy and paste between Excel. We can also set up data adapters that would automatically load in the projects from pre-configured databases or templates. So once the projects are loaded into the system, one can run a Monte Carlo analysis, and then for every individual project we will have a distribution of the NPV for that project, and also a confidence table which we can use to very quickly read off the probability of achieving various NPVs. So for example, there is a 20% probability that we'll have just short of $60 million NPV from this new beneficiation unit project, but there's an 80% chance that the NPV will be at least $30 million. So we could say that the most likely range is between $30 and $60 million for this project. And you can also look at the same histograms and probability charts at the level of a group of projects and for the portfolio as a whole. So in our case, our portfolio could be anywhere between $240 and $90 million. But the most likely value is somewhere around the $200 million mark. So the next step that we can do is to have a look at the trade-offs between the various projects that exist in the portfolio. And this is the classical style of portfolio management, where you'd put typically NPV on the vertical axis to measure the return of the project, and then on the horizontal axis you would look at various other measures. In this case we're looking at a risk factor, which is the relative downside risk, the P95 downside. One could also measure against the standard deviation of NPV, the payback period, the IRR, the amount of capital involved in that project. And one can use that to get a sense of which projects are high capital, which of them have a good return to capital ratio, which of them are particularly risky, and which of them are quite low risk projects. Now, of course, the point of looking at the risk is that it's something that's quite difficult to do with conventional portfolio planning, And so by using the proxy of the low road and the high road estimates for each of the projects, we can get an objective assessment of what that risk is likely to be. And that allows us to make good trade-offs. For example, we can see that although the fleet management system has a fairly good return, it is also quite high risk. And the flotation refurbishment has only a slightly smaller NPV, yet it is much less risky. So one would argue that the flotation refurbishment is a much better choice to make if one is very risk averse. You can also have a look at these trade-offs on the group level. So we can see that capital investment projects tend to be very high return, but they also tend to be quite high risk. Mine improvements are medium risk but relatively low return, and then the plant improvements off to the left are very low risk with about the same level of return as mine improvements. So immediately one could say that if one was forced to prioritize capital, the plant improvements might be the first place to look at. Now, the next step is to choose a portfolio of projects, in other words, a selection of which projects go ahead and which do not, which would lead to the ideal combination of capital investment, risk, and NPV. And the first thing that one could do is have a look at the various options for the portfolio. You can create a new portfolio using this control in the top left. I'll call it example portfolio. And within that there are really two things that you can do. The first one is to schedule various of these projects to start at an earlier or later date. And in fact, one can see the effect on the net cash flow as one moves projects in and out. So by shifting some projects out, I will be deferring some of that initial negative cash flow representing the capital investments. And one can also switch on and off entire projects and see exactly what effect that has on the cash flow. So we can see that the beneficiation unit was quite a high capital project, and that's represented by the purple area on the cash flow chart. And so by switching that off, we end up with a relatively low capital portfolio. At the same time, it's showing us a list of constraints that we've set up on the portfolio, and which of those are satisfied by our current selection of projects and timings. Now, those constraints can also be configured. So we have a constraints configuration screen, and here you can see I've set up three constraints on net cash flow, capital, and the blended risk measure, which is a P95 downside risk for the portfolio as a whole. And the net cash flow constraint is set at minus $40 million. At the moment, this portfolio does not satisfy that constraint, because in year one we would be laying out about $70 to $80 million. There is also a capital constraint currently set to $40 million, and again we're exceeding that constraint in the first period. And I've set a risk constraint to say that we want no more than $70 million of downside risk in the portfolio that is eventually assembled. And one can add new constraints by dragging on constraint objects into the list and configuring them to look at other measures such as IRR, for example, or the payback period, or even more esoteric examples such as the number of directors who would need to be involved in the project, assuming that that's a limited resource that has to be shared between the projects in the portfolio. So of course, building a portfolio by hand could take a very long time indeed. Even with just 9 projects in the portfolio, there are immediately 500 permutations of switching the projects on and off. And then when one takes into account the time shifting possibilities for projects, the number of permutations runs up into the hundreds of thousands. So to find an optimal portfolio by hand could take some time. So for that reason, we have an optimization capability built into the system, and all that one has to do is create a new portfolio, and we could give it a name, optimized portfolio, for example, and then allow the optimizer to run. And what the optimizer will do is, using a combination of Monte Carlo simulation and a search through the various permutations of portfolios, it will look for the highest NPV portfolio that satisfies all of the constraints we set up earlier on. Now, this process will take a few minutes for the machine to run, but for a large portfolio of projects, it is far more efficient to do this by computer than by hand. So for our portfolio of 9 projects, it's expected to take about 2 minutes to run through and find reasonable optimization. And as soon as that is complete, we'll be able to have a look at the choices that the optimizer made about which projects are switched on and switched off, and any timing shifts that the optimizer has chosen to make. The optimization is now complete, and the optimizer has found a portfolio that satisfies all of the constraints that we set up. It was targeting the highest NPV that it could find, subject to those constraints. Now, what's really interesting about this is that when we do a straight line calculation of the expected return on all of our projects, and we add it up for all of the projects together, we get a fairly high value, around 320 million. However, when one runs a Monte Carlo assessment, which takes into account a balance of probability on the low road and the high road for each of those projects, in fact, the average NPV that comes out is closer to 200 million. And the optimized portfolio that the system has discovered, actually on a 50% confidence level, is around about at the same level as running all of the projects. But notice that this thin grey line representing the optimized portfolio has a much smaller slope, which means that there's a lot less risk involved in the optimized portfolio, even though in the P50 case it gives you about the same return. So how the optimizer has achieved that is really by switching off 2 projects which contribute more risk than return, and by delaying the implementation of the beneficiation unit by 19 months, which then satisfies the capital constraints that we had set up. So essentially we run all of the other projects immediately, and then we delay our big capital investment by a few months until we have built up the cash flow. Now, the real power of this is that it takes some portfolio planning techniques that are fairly sophisticated and normally only used at quite specialized organizations, and it makes them accessible to almost anybody. And in fact, we can use the same tools on quite a small scale for projects that are not necessarily millions of dollars of capital investment. For example, a new marketing strategy for a small business, which might be an investment of perhaps $100,000. So with a library of pre-configured project types and the drag and drop capability, plus the ability to import and export to Excel, and then run Monte Carlo at a click of a button and run optimization at a click of a button, one has quite a powerful tool that within 5 minutes could be set up to assess a business's projects for the next 6 months. And that ability to do it quickly means that you can also do it regularly, which can then tie into an improvement in the allocation of resources within the business. The fact that it has very flexible value driver trees which can be adapted to the purpose of the business means that we can also take into account all of the resources which are not necessarily a big deal for a large company, but for a small company such as SciEst, for example, really make a difference. The amount of director time that might be required for a project, the amount of the number of analysts that would have to be dedicated coming out of a limited pool. So you can apply the traditional portfolio planning techniques to some very non-traditional considerations. Now, this is obviously a prototype which we built in our Querent system, but if it is something that we can find a good market for, then we can very quickly put it up onto our web platform and scale it out to dozens or even hundreds of users very quickly. And because the projects use the flexible value driver tree technology in Querent, we can very quickly roll out new project types with a different driver structure, which would be suitable for a wide variety of businesses, both large and small.